This problem involves linked int list. We're asked to solve a basic traversal problem with the linked int list. So we're asked to write a new method for the class called hasOddEven that returns true if the list of integers contains at least one odd and at least one even. So we have some examples here of things that might be in the list and the value we're supposed to return. So here there's a bunch of even numbers, but there's an odd at the end, so it would be true that there's at least one of each. Here they're all odd numbers. Here they're all even numbers, so we get a false. Shorter list here, but there is one even among those three odds, and so it would be true. This is kind of a minimal case of one even and one odd. We'd get true. And we might have just a single value or an empty list. And of course the answer would be false in those cases. So I've set up a JGrasp file that we can use. It has each of these different test cases in it using the array initializer syntax. I add them into our linked int list and show what result comes back from a call on hasOddEven. So I have the linked int list class here. Our task then is to introduce a brand new method. It's returning a true or a false, so it returns a Boolean result. It's supposed to be called hasOddEven, and it's supposed to return whether or not this list has at least one odd number and at least one even number. So it's a basic traversal problem. It's going to look a lot like our standard traversal. We'll have a list node current that we can start at the front of the list. Remember that there's this field called front that keeps track of the front of our linked int list. And we would say while that current is not equal to null, we would want to keep going through the list. So here inside we're going to do something with current.data. That's the basic pattern, and we will reset current to be current.next. So that's the idea. While we're not at the end of the list, we'll deal with the current bit of data, and we'll set current to be current.next to go to the next thing in the list. So that's the basic traversal pattern that we want to use. Now here we're supposed to be keeping track of whether we have seen an odd number and an even number. So there's lots of things we could do. We could be counting odds and evens, for example. This is a case where all we really care about is, have we seen an even number? So it's a nice place to introduce a Boolean flag. We could say even is initially false and odd is initially false. That would be a way of saying I haven't seen an even and I haven't seen an odd. And then what we could do here with our current.data is we could say if current.data mod 2 is 0, then that would mean that it's divisible by 2, and that would mean that we've seen an even number. So we could set our even flag to be true. But what if that's not true? What if it's not divisible by 2? Then that means it's an odd number, and so we could set our odd flag to be true. So depending upon what we're looking at, an even or an odd, we either set the one flag to be true or we set the other flag to be true. So this would go through the entire list, setting even and odd to true. So one of the things we could do is we could kind of then have a return here where we said that even and odd, that we could say if we've seen even and odd, then that's what we were looking for. This would actually work, but it would be somewhat inefficient. The idea is that as soon as we've seen at least one even and at least one odd, then we have an answer. So we might as well go ahead and return that answer if we have it. So this is a better thing to incorporate inside the loop. We can say if even and odd, if that allows us to reach a point where we've seen each, then we would return true. So we can stop executing the method, break out of the while loop, and return if we know we've seen both an even and an odd. If we ever get to this point here after the while loop, that means we went through everything and we never saw a combination of an even and an odd. So in that case, that means that we would return false. That would mean that we actually hadn't seen a combination of an even and an odd. So let's go ahead and compile this version of the code, make sure that that works, and then let's come over and compile our client code, and we'll see whether this runs properly. When we run it, it tells us that for this first case we get true, then we get false, false. So we have a true, false, false, true, false, false. That looks good. And then after those three cases of the true, false, false, we have true, true, false, false, false. And we have over here true, true, false, false, false. So it actually worked in all of the different cases that we had there. So if we go back over, we can take a look again. This then is our solution to that problem.